And then image made. There we go. Okay. So recording has begun. If you want to stop putting on a show or start putting on a show, it's completely up to you. All right. So here's the idea. We're going to walk through step by step what should be going on in your head. All right. You're going to take your quiz Friday home. Short. It's like 5 questions. It really is short because we're going to spend the rest of the time starting 5.2. That big old packet that we're going to go through. Okay. That would be me.
Is the quiz like, is this quiz on like the really difficult stuff?
The quiz is mostly.
Oh, perfect. So this is the difficult stuff or no?
It's the more difficult stuff. So the stuff you did that we posted the solutions for, my belief is that's the easier stuff. Because they give you specific directions involved in numbers. This is the algebra part. So this is what we started on Friday.
Okay.
All right. So here's what you do. Simplify the expression secant theta minus tangent theta sine theta. So you have multiple trig functions. Number 1, do you have a GCF? Which you do not. You do not have any trig functions that show up twice. Agreed?
Yes.
Okay. So step 2 is see if you have anything squared. Because then you can use Pythagorean identity. Nothing in luck. Now you go to your last step. So when you don't have fractions in your last step, all right, is rewrite everything in terms of sine and cosine. So if you have nothing squared, no GCFs, no fractions, your last step is sine and cosine. So basically what happens with that is secant becomes 1 over cosine. All right? Because that's a reciprocal identity. Tangent is sine over cosine. And then sine is just sine. Your choice if you want to write the theta over and over again, it's completely up to you. Okay? So everybody good with that? All right, so the last one, the sine theta turns into sine theta over 1. Now you're going to simplify. Every step you show gets you credit. So 1 over cosine theta minus sine times sine would be sine squared over cosine theta. Okay.
How do you get sine squared?
Sine times sine. The sine from the tangent and the sine from the original sine. Now you got fractions. So now your next step is a common denominator if it doesn't already have it. Does it already have a common denominator? Yes. So we rewrite it as a single 1 minus sine squared theta over cosine theta. We're 3/5 of the way home. Now you have something squared, which is your Pythagorean identities. 1 minus sine squared is equivalent to cosine squared. So we rewrite it like that. All right. Now, whenever you have something squared divided by it, the squared cancels out. And so my final answer would be cosine of. Now, you didn't hear this from me. But if you're stuck, and you want to know if that's the correct answer, here is my suggestion. Plug in an angle method. 30, 45, or 60. Because if we do, let's say, cosine of 45, that would come out to root 2 over 2, which in your calculator would be 0.707. Do the same thing here, and your answer should come out to be the same number. It's a little complicated putting secant into your graphing calculator. I understand that, but that'll work.
How do you do that?
Secant. So if you wanted to do 45 degrees or radian, would you put it in degrees or radian? You would do it in degrees, right? Okay. So basically, if you want to do the secant of 45 degrees, all right, it's 1 divided by, and secant is the inverse of what? Cosine. So cosine of 45. All right, and you get that decimal. All right, minus, and then parentheses, tangent of 45 times the sine of 45. And it gives you that.
It should be the same exact
It should be the same as your answer, yes. Mine's in radians, not degrees, so we messed it up. You got me, so if I go back to degrees and do the same thing, 1 divided by cosine 45. All right? And then minus tangent 45 times sine 45. You get that, the 0.7071. And then you go, okay, cosine of 45. And you get the same. So they should come out to be exactly the same. All right? Now, simplify the expression, cotangent squared over 1 minus cosine squared. I'm going to leave the cotangent squared, because that's by itself. I'm going to work with the 1 minus cosine squared. 1 minus cosine squared is sine squared. The cotangent squared, then, you can use it just like cotangent, quotient identity. Cosine squared over sine squared. What do the sine squareds do to each other? Cancel out, leaving you with just cosine squared. All right. Now, again, following directions is the key. They don't say simplify in this one, they specifically say to factor. All right? So the first thing you look for is a GCF. Do they both have a cosecant x in it?
Yeah.
Yes. So that becomes cosecant x. And then when I factor it out, it's cosine squared x minus 1. Okay? That is the opposite of 1 minus cosine squared. Does everybody understand? Whenever it's either sine squared or cosine squared minus 1, and we'll walk through all this on Thursday, how the Pythagorean identities can look differently. That's what we're going to do first thing Thursday. So if that's the opposite of 1 minus cosine squared, that means it would be the opposite of its equivalent. In other words, that's negative sine squared x. Cosecant x. Now you look to see the reciprocal identity if that helps us simplify. 1 over sine x times negative sine squared x. Positive times a negative makes my final answer negative. Sine squared divided by sine is just negative sine x. All right. Good. Next one over, 2 cosecant squared theta minus 7 cosecant theta plus 6. They're all in cosecant squared, one of them squared, one of them single, it's all the same trig. That tells you you factor like a trinomial. If you'd like, you make x equal to and this is completely optional. X is equivalent to cosecant theta, and this becomes 2x squared minus 7x plus 6. All right, and then you're going to factor. Is there anybody who would like to see a specific way to factor besides slide and divide? A times c, which is what? 2 times 12. So x squared minus 7x plus 12. What two numbers go into 12 add up to 7? 4 and 3. Then what was our original coefficient? 2. So we bring that back and put it under our constants. Does 2 go into 4?
Yeah.
So that simplifies down to x minus 2. 2 does not go into 3, so we move it up as part of the coefficient. And now, Jada, what did we make x? Cosecant theta. So our final answer is cosecant theta minus 2 to cosecant theta minus 3.
Answer.
That's the final answer. These are going to make a lot more sense when we solve equations. Because then basically what you're going to do is you're going to set those equal to 0 on top. Remember how you solve quadratics by factoring? You're then going to take those and set them in equal equations. So this, you don't follow this part? Okay, did you do slide and divide, or did you do a different method to factor? You, okay. So do you want me to just show you this way and that's easier for you, or do you want me to? Okay, so basically, so you're good with here, the x squared, you're good with this? Okay, so you do 2 times 6 is 12, you factor that, x minus 4, x minus 3. All you do is take whatever your lead coefficient was in the beginning of the problem, and you put it under your constants once you factor. So that's the 2 and that's the 2. If it goes in evenly, you divide. So on the one on the left, 2 goes into 4 twice. So that's why that's just x minus 2, you all right? For this part, it doesn't go into it evenly. All right? So after you reduce it, so like if this was 4 over 6, you'd have to reduce it first. But this isn't reducible. Once you get to that point, simply take that and put it up there in front of it. So that's a 2x minus 3. All right? So basically, you're kind of working backwards with solving, but that's the idea. As soon as you reduce your fraction, just take whatever your denominator is, put it in front of your variable. Good? All right. Next one, cotangent squared x minus 2 cosecant x minus 7. All right. Now, they're not the same. So you have to rewrite it using the Pythagorean identity. Cotangent squared, 1 plus cotangent squared equals cosecant squared. All right. If that doesn't work, if that's not equivalent to that, then there's something else that's got to be going on. Everybody good with that? Yeah. We want to get the cotangent squared, so we want to get that by itself. How do we get rid of a plus 1? Subtract. So cotangent squared equals cosecant squared minus 1. So I'm going to replace cotangent squared with cosecant squared x minus 1. All right, the cosecant squared x will be all by itself. The minus 2 cosecant x will also be by itself. We're just going to put together the negative 1 and the negative 7, which gives me negative 8. What numbers go into 8? Subtract the 2. 4 and 2. So it's cosecant x minus 4, cosecant x plus 2. Yep. All you're doing. It's telling you to factor. So that's it. You make sure you follow the direction. Sure. No worries. All right. Everybody good thus far? All right. The next to last part. All right. And this is the last thing we did the other day. Rewrite the following so that they're not in fractional form. All you want to do is make sure that it isn't a fraction. After that, you're done. Don't do anything else. Because they're giving you specific instruction that it's not in fractional form. When it's an expression like this, 1 plus something or 1 minus something, you multiply by the conjugate. So I multiply top and bottom by 1 minus cosine. I don't know. And if I had to do it over again, I wouldn't have used it. I think I just got bored, so I used a different symbol, and then I realized it's a different Greek letter, whatever it is. It's like alpha, beta, gamma, omega, whatever. Okay, everybody good with that? The conjugate. All right. Everybody understands when we multiply by the conjugate, the outers and the inners cancel out. So my new denominator is going to be 1 minus cosine squared of that expression.
How do you get that?
1 times 1 is? 1 times a negative cosine is negative cosine. 1 times a positive cosine is positive cosine. What's the negative cosine and the positive cosine going to do to each other? Cancel out. And then a positive times a negative is a negative. Cosine times cosine is cosine.
Oh, that's true. I thought that was equal.
Nope. Okay. Now the top. Sine of that symbol times 1 minus cosine of that symbol. Okay. When you multiply the conjugate, I would hold off on distributing up top. Because 1 minus cosine is equivalent to sine. This becomes sine of that over sine squared of that times 1 minus the cosine of that. So that's all it becomes. All right. Now, when I do sine over sine squared, do you agree one of the signs cancels out?
Yeah.
So I'm going to be left with the expression 1 minus the cosine of that symbol over sine. When you have multiple terms over a single term, break it down. So what's my first term in the numerator? 1. So I write it 1 over the sine of that. That's a minus sign, so I keep that. That trig function is a cosine. And now you use your reciprocal identities and quotient identity. That's the point of all those. So 1 over sine is cosecant. So that becomes a cosecant of that symbol. And then cosine over sine is cotangent. So there's my final answer. Cosecant theta minus cotangent theta. Again, there's nothing else you do with it because it's no longer a fraction. It's done. That's all it is. All right. For the next one, what's the conjugate of 1 plus cosine? 1 minus cosine. So I multiply top and bottom by 1 minus cosine 1. So this becomes sine squared y times 1 minus cosine y over 1 minus cosine squared y. One minus cosine squared y is equivalent to sine squared y. So this becomes sine squared y over sine squared y, 1 minus cosine y. What do the sine squared over y's do to each other? Cancel out. So your final answer is 1 minus cosine y.
So 1 minus cosine? Yeah.
1 minus cosine y, because sine squared cancel out. Okay? Good? All right, the last one that's, well, then again, last one in this section, next to last problem. It's only a single term, so you don't do the conjugate. So you just rewrite each term over that denominator. So sine w over sine w plus tangent w over sine w. What do the sine w's do to each other? And you got 1. So that fractional part is gone. Now here's the tricky part. You have a rational function with a quotient identity in it. So basically what I have to do is this. So it becomes tangent w divided by sine w. All right? Which becomes tangent w times 1 over sine w. And this is the first thing we did the other day. Whenever you have 1 over a trig function or any number over a trig function, this is all you're going to do. Don't worry about the y. Just move it from the bottom to the top and then figure out the reciprocal identity. In other words, what's the reciprocal or the inverse of sine? Cosecant. So this just becomes cosecant w. So it's tangent w, cosecant w. Now, is that now in fraction form? No. Remember, what do we have in the very beginning, though? The 1. So my final answer would be 1 plus tangent W cosecant W. And I've met my requirements. It's no longer a fraction. Give me 1 second. What's up?
Why can't we just right from the beginning cancel out the sine W's and then just cancel tan W?
Because the sine W only cancels that. It doesn't cancel that.
Because it'll leave us to the tan W, but not.
3x plus 5 over x is 3 plus 5 over x. Just because they cancel one part of the polynomial doesn't mean it cancels all.
Sure.
Okay? Yeah. Now, we've met our requirement, which is 1 plus tangent W. It's not a fraction. However, what you're eventually going to have to do when we simplify, and this is 5.2, tangent is what? Sine over cosine. Cosecant is 1 over sine. What do the sines do to each other? Cancel out. And we got 1 plus 1 over cosine, which is 1 plus secant. You don't need to do that yet, because what does that turn this back into? A fraction, and we don't want that. But I'm just telling you, eventually that's the point we'll get to. Now the last thing, which is the easiest thing to do, and please don't ask me what's the point, because I don't know what the point is, but it's 3 points, so let's give them to you. It says use the substitution x equals 9 cosine theta, 0 is less than theta is less than pi over 2 to write 81 minus x squared as a trigonometric function of theta. Now, this is setting you up for calculus for whenever you do it. That's the only point to this. So this is what we do. We rewrite the square root of 81 minus x squared. Then we take whatever the x is, and we replace it with whatever they tell us it's equal to. So that's the square root of 81 minus, and then x is 9 cosine theta squared. That's it. That's the first part. Now you're doing some math. 9 squared is what? 81. So 81 minus 81 cosine squared theta. So underneath a what? Square root. Do they both have an 81 in them? Yes. Yes, more often than not, that will be the case. So I quote unquote factor that out. All right. What's the square root of 81? So the 9 comes outside. 1 minus cosine squared is the same thing as sine squared. And whenever I do the square root of something squared, what do they do to each other? Cancel out. So your final answer would be 9 sine. If that's on the quiz, we'll spend more time with that on Thursday. I don't know if that's on the quiz or not. I don't remember it being on there. All right. But for the most part, does everybody understand everything else that's there? Okay.